Hi everyone, thanks for coming to my talk. I'm going to be talking about what first-party oracles are and why they're important. My name is Dave Connor. I lead blockchain-focused business development for API3. API3 is an oracle project that focuses on creating a network of first-party oracles operated by as many data providers as possible and governing them all in a truly decentralized way. So to start with, I think it's worth running through what oracles actually are, in case anyone in the room isn't aware. Basically, blockchains are unable to natively access any information that's stored outside the blockchain itself. So an oracle is a general term for middleware that connects blockchains to real-world data. Oracles aren't anything related to Oracle, the software company. Oracles come from a term in ancient Greece where the oracle was the person who could see what the gods saw and translate that to something that people needed to be aware of. But the question really here is, where does the data come from? An oracle provides data to the blockchain, but oracles aren't normally the source of the data that's being posted onto the chain. Most oracles are operated by people or entities who post API data on the blockchain itself, and smart contracts and dApps will use the data once it's on the blockchain. The actual data comes from data providers. These are generally API providers, which are companies that focus on providing data to consumers. Most of these API providers' consumers are Web 2 applications. They tend not to be Oracle-focused. To go a bit more into that, an API is an application programming interface. It allows an application to interact with an external service. This uses a specific set of commands, and APIs themselves are the building blocks of Web 2. They allow feature-rich applications to be built, and most of the apps you use on your phone will be a connection or a collection of various different APIs stitched together in different ways. So an example here is Uber. So Uber at its simplest is a communications API, a mapping API so you can see where your taxi is and how far it's taking you, a location API, and a payments API. There's a few more around that, but it illustrates how you can create quite a feature-rich application by picking and choosing various functionalities for it. So you have the data and you have the oracle. And this leads you to something called the oracle problem. And the oracle problem focuses on the issue of having to trust a third party to relay data from an API provider accurately to the blockchain. Using the API providers that I had on the previous slide as an example, if you wanted to find out what the price of a coin was from, say, CoinGecko, you would then have to rely on that single oracle putting data correctly on chain. They could tamper with that contract by putting false data there. So these third parties control what data ends up on chain, not the data provider. Most Oracle projects around today aggregate between a selection of oracles to try to mitigate this and reduce the risk, but collusion between oracles is still a potential risk. So the logical question from that is, does data have to be relayed onto the chain by a third party? And we would say it doesn't. So starting here to define an oracle type, a first-party oracle is an oracle where it's operated by the data source themselves. So rather than the workflow going data source to oracle, even if it's an oracle network, to blockchain, it goes data source to blockchain. Third-party oracles are oracles operated by parties that are not the data source themselves. And this includes oracles being operated by a third party on behalf of the data provider, which is important because those kind of oracles, if they're claiming it's first party, it's a bit disingenuous because the security implications are completely different. And that's a slide just dedicated to the definition. The question really, the second question for this presentation was, why should I care? Why would you use first-party oracles, and why does it matter what they are? Well, there are a few advantages to choosing first-party oracles over third-party oracles. And the big advantage really, or the first advantage is security. So there's no need to expose data to third parties, which include which makes things like enterprise and banking use cases much more easy to integrate. You don't have a third party that sits in between the data and the blockchain. If you have a private blockchain or a blockchain with confidential smart contracts or confidential dApp capabilities, you don't have a third party that the data has to pass through. The data source will post directly to chain, and there the confidential aspect can take place. Equally, if you have a private or an enterprise chain, then it will work without needing to choose third parties, KYC them, have them sign NDAs, etc., etc. It's a lot simpler. You also have an increased Sybil resistance compared to a third-party Oracle project, simply because there's no Oracle layer to collude. So no matter what processing you do on third-party oracles, you're still making a security compromise over choosing first-party oracles. And the logical thing that follows on from this is, can the API providers collude? And the answer is yes, they can, but they also can with third-party oracles. The risk there, though, is much more obfuscated. With first-party oracles, you can see exactly who's putting the data on the chain, rather than them being obfuscated behind a third-party oracle layer. And without the source of the data being known and the API provider attack being obvious, it becomes harder to detect and harder to punish. Another advantage of first-party oracles here is uptime. So if you have a first-party run oracle, if you can run the oracle in the same cloud infrastructure as the API itself, then the uptime should be identical. There's, of course, no benefit to having an oracle that's still up if the API provider is down, because it won't work. But having an API provider that's up and unable to push data to chain if a third-party oracle is down is bad. Another big advantage of first-party oracles is the transparency that they bring to data on the blockchain. If you can identify data on-chain as coming directly from the data provider using their oracle address, ideally, then it provides complete traceability for the data that dApps use. If you're used to using Etherscan to check what code dApps have to track transactions, to view the movement of tokens, you're used to being able to track everything and treat everything as being completely upfront and transparent. But for most of this today, that ends just where the data comes in. So you can see how a lending market ends up executing a swap or a transaction, but you can't tell where the data used to calculate how that ends has actually originated from. First-party oracles changes that. It makes it so you can see exactly where the data comes from that's used to execute on-chain logic. And it brings this level of transparency an extra step further than is present at the moment. This follows on from transparency, really. You end up with a much more accountable data feed structure or a much more accountable data use structure if a data provider provides directly to the blockchain. Blockchain is a permanent record, so it becomes tamper-proof. If a data provider misreports, that will always be there. That will impact on their real-world business model, and it will be visible forever. If you hide this behind third-party nodes, this isn't necessarily the case, because they could always claim it wasn't them, or it might be difficult to ever evidence that that misreport comes from the provider rather than the nodes themselves. Another advantage to first-party oracles is the cost. Third-party oracles aren't a charity. They need payment for their services. You have to aggregate between different third-party nodes if you're using a single API source, and aggregation requires payment of multiple nodes. So first-party oracles involve no payment other than to the data provider itself. So for a given data source and a given data feed construction, the first-party selection should always be cheaper to operate, unless you have charitable third-party nodes or you're willing to subsidize them. And to be fair, there are some disadvantages of first-party oracles. Most of these come where people are using third-party oracle designs and trying to shoehorn them into getting API providers to run them. These kind of oracles can be hard to operate. So the Coinbase API, the Coinbase Oracle, I've heard apparently requires 2 full-time blockchain developers to operate. So if you go to an average API provider and explain to them that you have a great use case for them on blockchain, they need to operate an oracle as a first party, and say then they need to hire 2 full-time blockchain developers, they're going to tell you no. If you have to monitor it and top up gas wallets, a lot of existing data providers aren't that interested because it might be against their compliance models. It might be something that they just don't know how to do, or it might be something that they see as a legislative risk or a compliance risk. So the other disadvantage is you have to convince the provider to operate them. And this leads to independent contractors being used to operate them for providers, which isn't a first-party use, as I was saying earlier. So are there any first-party specific oracles? We created one, that's API 3. We have a free-to-use open-source Air node designed to be operated by data providers. We have over 3 times as many first-party providers as the nearest competitor claims. And we're launching Beacons, which is first-party operated data feeds on ETH and Polygon testnets at ETH Denver. They'll be available in our hackathon track. We're sponsoring the DeFi track for ETH Denver itself. So Beacons aims to provide fully transparent, scalable, and cost-efficient data feeds with bounties available for people creating projects using them. And that's everything, really. Does anybody have any questions? If I've got time.